I'll start. Hello everybody, good morning. Thank you for queuing or whatever to come in here. Can everybody hear me? Can everybody understand me? Okay, I apologize because there's a lot of stuff to go through here and I've got 20 minutes, so it's going to be quite fast. So grab your coffee and kind of hold on for good luck. First of all, who knows what matrix is already? Wow, that's petrifying, honestly. Okay, well the good news is that we can probably skip very quickly through the first bit, which is a kind of generic, hey everybody, this is what matrix is. So matrix today, because the point of this talk is to compare where we are today and crazy sci-fi for the future, is obviously matrix. We're a non-profit open standard. It's all about defragmenting communication. And the idea is that we build some kind of meta network which goes and links together all of the silos out there today, whether that's Slack or WhatsApp or IRC or whatever sort of bubble of communication we have today, and we link them all together with a lowest common denominator, decentralized fabric that liberates communication to be controlled by us. So in practice, you have a whole bunch of silo bubbly things, and it could be a community on Gitter, it could be a community on Slack, on IRC, XMPP, Skype, whatever. It could even be an application like GitHub, which needs to be integrated into this with some kind of bot. And you go and slap matrix in the middle as a whole bunch of servers where you have conversation history that is decentralized across all of the different bubbles. So suddenly they're no longer trapped inside, say, Slack. Instead, it kind of functions like a bit like Git, but for chat history or communication, conversation history itself. So you have bridges that go through to various different silos, and then the core network is a full mesh of servers which store the conversation. You can have native matrix clients that connect to that, and that's basically matrix in a picture. Whole point is that no single party owns the conversations. The thing aggressively decentralizes the conversation so that if I'm talking to somebody on a different matrix server, that conversation has to be replicated over both so that if my server goes down, they can continue communicating. And that's kind of the main core unique thing about matrix, that it literally subversively, aggressively stops the ability for you to form a walled garden or a silo. And obviously, the conversations end up replicated over all the participants. You can use it for group chat, you can use it for VoIP signaling, bridging any kind of silo. It's kind of fun for IoT data because it acts in the end as a great big open JSON database, basically, where you can publish any old object out onto the web and people can subscribe to it. It gets persisted and replicated around the place. And in some ways, we like to think of it a bit like an evolution of the web itself, kind of a step towards the read-write kind of dynamics of the web that Tim Berners-Lee was originally kind of aiming for. So in the end, in the simplest case, if I want to send you a message, I do an HTTP put to my server, it fans that out to the other servers, and then you on your servers will do an HTTP get to get the object. And it's as simple as that. It doesn't have to be HTTP, but that's the baseline kind of lowest common denominator, stupid, simple transport that we use, because everybody knows what HTTP is. Some people are probably thinking, why are you inventing XMPP? Is anybody thinking that? Or can I skip the next two slides? Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got about 10 people saying, why are they reinventing XMPP? Our take is that we're really not, as in they are very, very, very different things. I mean, critically, probably the single biggest difference is the difference in philosophy and architecture. That in Matrix you have one spec. It currently is at 0.2.0, and we're way overdue a 0.3.0 release. And if you implement that, you get Matrix. Now, bits of it are optional, so if you're implementing it on an IoT device, and obviously you don't want to do video calling, or you don't want typing notifications. So there are different bits of the spec which are optional for different use cases, but in the end, it is a single consistent spec. So that's probably the biggest difference. Then at the architectural level, the primitives are also completely different. Matrix is not message passing. I'm not checking an XML stanza to you, sir. I'm going and taking my eventually consistent history of the room and replicating it over to you. It's the difference between doing a git push and, I don't know, sending an email, if that makes any sense. Also, everything is group conversation. So you have rooms and you have people in the rooms. If there are 2 people in the room, then it's a kind of direct conversation, but that's very much a subset of the general idea of group conversations. And also, almost end-to-end encryption is in there as a first-class citizen in the whole protocol. Obviously, the difference is that we're using HTTP and JSON, but it's not XMPP with JSON. As I said, it's got very big other differences. And finally, I guess a big sort of philosophical difference is that we're not trying to be kind of the XKCD 15th standard that solves everybody's problems. Instead, we're going and focusing on bridging together all of the other silos. So if you want to keep using XMPP, please do. If you want to use IRC, like I do, please do. The only point here is to just have a protocol really optimized in some ways for bridging. And if you want to use it natively, that's cool too. So actual architecture, kind of already touched on it. Full mesh of servers, clients connect to servers. Application servers are a bit like clients but on steroids. It rips off the IRC structure where you have an IRC AD and then you have IRC services like NICServe, which basically are users but they have superpowers. Same architecture here, the application services that allow you to build arbitrary functionality and bridge to other things. And they kind of hang off a server like a big client. And then finally, the interesting one for this talk, at last, I've been wanting to do this talk for ages, are these slightly suggestive looking identity servers going and sitting in the corner. And they honestly are an embarrassment. So identity servers, I'll talk about in a minute, but basically they map third-party identifiers like email addresses and phone numbers and Facebook IDs, whatever, into Matrix's internal IDs. And at the moment, these are logically centralized. This one is matrix.org, and that one's running on vector.im, but it's basically a single database that maps identity. The one thing you need to know is that it's only mapping identity. It's not where your accounts live, it's not where your passwords or anything live, it's literally just a naming service that says, hello, this email address maps to this person on Matrix. And this is one of the big embarrassments of Matrix and one of the things in the future that we're hoping to fix. Ecosystem as a whole, main deliverable is the spec. We provide a bunch of server implementations. Synapse is the only one that you can really use today. It's Python and twisted. It hit 0.19 yesterday, and it actually doesn't suck anymore. I mean, it's honestly, it's taken us 2 years to get to this point. It started off as a proof of concept that was very inefficient, very organically grown, and it's then grown even more. And over the last couple of 6 months, we've kind of been collapsing it back down to be a sensible size. And certainly as of 0.19, it now uses an almost reasonable amount of RAM and is almost kind of efficient. So for instance, on the matrix.org server, we're taking in about 10 messages a second and pushing out about 2,000 messages a second because the rooms are so big, and that's taking about 40% CPU fairly flat and admittedly quite a lot of RAM there. But my personal one's now running at about 350 megabytes of RAM, which you might think is, wow, relative to a little XMPP server is huge, but it's doing a lot more. We also cache a lot more. It's not perfect, and more excitingly, and I'm not going to talk about it much, is Dendrite, which is the code name of our next-gen home server, which we're writing in Golang, which we're aiming to be at least a couple of orders of magnitude, like literally an order or two of magnitude faster than the Python one. And then we've got bridges that connect through to IRC and everything. Orange stuff is from the community, so we've got lots of servers like Rumor in Rust being written by the community, and lots of gateways and bridges and services. Then on the client side, we provide the JavaScript stack, the iOS stack, and the Android stack. And this is split into 3 layers, in theory. The HTTP wrapper, then the kind of UI components, and then the app itself at the top. And we have some very ugly kind of reference apps. And then you have Riot, which is a flagship, kind of really glossy, hopefully really glossy app built on top of those. And then meanwhile, the community have lots of different clients in different languages if you don't like any of those. So what do you get? Very quickly, conversation history, group messaging. End-to-end encryption is the big new one throughout the whole thing, currently implemented in there, and there. Therefore, anything on top of that gets it. We're looking at how to roll it out to everybody else as well. VoIP signaling, push notifications, yada, yada, yada. You get the idea. It's sort of parity with everything you'd expect from a communication system. So what does it look like? Very quickly, let's go and look at Riot. So here's Riot, having loaded a totally random room. Let's go to Matrix at FOSDEM. And that's our internal room, people comparing their pain raison. And this is the dark skin, by the way. If anybody has ever got upset that Riot was very, very bright before, this is now what it looks like if you turn on the dark skin, and it makes your eyes hurt less. If we go to a big room like Matrix HQ, then this has got 6,000 people in it, and they're spread over about 600 servers. You can see that Matrix IDs here are of the form username domain, so it's a bit like an email address, but it deliberately isn't to avoid it being confused with an email address or a Jabber ID. You can see people chatting about the thing, read receipts coming down the right-hand side, doing a funky Tetris thing. Why does Slack still not have read receipts? If you want a chat system that has read receipts, come to Riot. On the left-hand side, I'm in about 400 one-to-ones in about 400 rooms, so we're kind of pushing the limits a little bit there, but in practice it works relatively well all the same. If I go and expand up the list, you can see I'm not even lying with all of my one-to-ones hanging around there. And we have it obviously on Android, it's on the F-Droid store from a FOSS perspective, and it's all great. Okay, let me stop talking about Riot itself and the interesting stuff. Oh, quick stats, basically. We started 2 years ago. We're up to about 750,000 accounts on the matrix.org node now. We've got 1,500 servers that we can see out there, which take about 50% of the rest of the traffic. So at the moment it is a bit centralized to the original matrix.org node, but the community and the ecosystem itself is growing out. Much better graph is this one, which is showing the messages per day going through matrix.org, and we've filtered out all of the bridged ones going through to IRC and XMPP, so this is the pure native traffic, and you can see we have this slightly scary exponential whoosh happening, which is why we spend a lot of our lives doing ops and optimization work on Synapse at the moment to support that. So let's get to the future, halfway through the talk. What are the big limits today? Identity servers, already touched on briefly, centralized accounts, and then the big ones, spam and reputation, and also metadata protection, but that's, I think I'm going to punt that to this afternoon's talk if people want to come and hear about it. So, identity servers, as we said, we have matrix IDs today. These are opaque. It's at username:/domain.org. The whole point of these is they're not meant to be human visible. We don't want people to put matrix IDs on their business cards. Ironically, I have one on mine, but that's a bootstrapping step. So instead, the idea is that you're meant to invite people by third-party IDs. So you take your address book on your phone, and you look at the email addresses, if you want, your phone numbers, if you want, or Skype IDs, Facebook, LDAP usernames, whatever the hell it is. We don't care. We just want to aggregate all of the other ones out there. And they just map, as I said at the beginning, from third-party IDs to matrix IDs. And the current solution is terrible. It's like 1,000 lines of Python running in a little HTTP server called Sident, and it's logically centralized. So this is a disaster, really, because you shouldn't be having to trust a centralized ID mapping server. Also, we've got the problem that the data is very sensitive because it's everybody's email addresses or a hash of everybody's email addresses or phone numbers, which is still quite enumerable. And it's also got sort of pseudonymous properties we want to protect. Identity mappings themselves have to be trustworthy, so we need, if somebody asserts that I own my email address, we don't want to get it wrong, otherwise they're going to be hijacking my account, basically. And we also have a problem of somehow needing to trust the reputation then of the validators. So if I am trusting some random third party like Facebook to claim that my Facebook ID maps to my matrix ID, I want to know whether I trust Facebook to manage Facebook IDs or not, if that makes sense. So possible solutions. This talk is not about telling you what the solution is, it's giving you some science fiction to muse on about the things that we're looking at the moment. Keybase is so close to this, it's untrue. Except it's still basically centralized, even if they publish the root of the mapping database that they maintain. And please, by the way, contradict me or if I get any of this wrong, because half of the point is hoping that somebody's going to come up to me after this and say, well, what you want to do is this. So please do tell me. It also doesn't handle email, and it doesn't handle phone numbers, which is a bit of a shame because those are the two main identifiers that people use for human communication. Something like Blockstack, which is obviously a blockchain-based way of broadcasting and identities, but they have the problem, as far as I can tell, that they basically blindly trust the identity validator, that if they let you on the network and you start asserting email things, then they basically say, oh, okay, then we let you on the network, and if you say that email address goes there, then we believe you. which is fine if it's a relatively closed network, but not if you're making it completely open. Then you have something like WebFist. Anybody know WebFist? Nobody knows WebFist, and I don't know why. So this was written by Brad Fitzpatrick at a hackathon a few years ago, and an indie web thing, I think, in Portland. And it's specifically for email. Uses domain keys to assert ownership on email. It's basically decentralized webfinger, hence the name WebFist. And it looks unpromising, but it's never taken off. It even works today. Persona had some characteristics of this for email, and as I'm sure everybody knows, poor old Persona, rest in peace. Then you've got other decentralized ledgers. There's Sovereign from guys at Evenym. You've got Uport built, Sovereign uses its own ledger. You've got Uport built on Ethereum. You've got Stellar, which is its own sort of ledger system. You've got Namecoin as a fork of the Bitcoin thing. These look promising for distributing the mapping data, but they still don't really solve the validated trust problem of who the hell do I actually trust to start making assertions onto this database. You can go down the DNS route, like the good old enum back in the day on sort of classic DNS. There's the GNU naming service as a sort of decentralized alternative to DNS. And then in the last couple of days, in fact, we've seen the community getting pissed off with us and saying, hang on, guys, come on, this sucks. There must be a better identity server than this. And somebody just contributed a Java alternative implementation of the same APIs called MXISD, which allows at least fall through. And it looks a bit like DNS for this sort of thing. And I'm really running out of time. So the moral of the story here, though, is that this isn't anything about Matrix. Everybody in this room, especially this room, needs it. I mean, it's basically the problem of saying, hello, I've got an email address. How do I map that to a Bitcoin ID? Or any decentralized thing. It could be an XMPP address. It could be IPFS hash. I don't care. And yet, we still haven't solved it. And this is a huge stumbling block to the evolution of the decentralized web. Decentralized accounts. Quickly. At the moment, the rooms are decentralized in Matrix. The accounts are not. Matthew on matrix.org is stuck on matrix.org. Means that we're bound to DNS. Means that it can't have backup home servers. We can't even do secondary MXs. We can't migrate, which is pretty crap. Possible features. Well, we can use the identity server to treat MXIDs as a kind of indirection layer and basically just say that, hey, Matthew on matrix.org should map through to these secondary ones. Kind of low tech, but would probably work quite well, and that's probably what we'll do. Alternatively, we could go the whole hog, ditch DNS, use public fingerprints for user public keys, and then you have mappings where you keep the MXIDs, but now they're a form of third-party ID, so you go and take your MXID, map it through to the public key, and then you use something like a DHT possibly to discover which servers are actually hosting that ID. Third one I had was spam. Unfortunately, spam is here today. And much of it is bridged from IRC. I'm sure some people here have had the unpleasant experience of receiving 2,500 room invites into their Matrix client overnight because some script kiddie on Mosnet went and enumerated a room and went and did PM spam to everybody, and the bridge dutifully bridged it all through into Matrix. On the flip side, we also have a potential disaster for messages going the other way, because having gone and bound everything into one network and put a simple HTTP API on it, unless we have very good reputation in anti-spam stuff, it just becomes the world's easiest way to ever spam people short of SMTP. So it comes in two different flavors, invite spam and public room spam. We can mitigate, this is mainly because we force an invite handshake for one-to-ones, but that still means that you can end up with 2,000 invite spam. And we're still starting to see idiots coming into public rooms and saying, oh, come and buy Viagra, or whatever. They're doing that both natively and being bridged in from other systems. We also had the complication that with end-to-end encryption everywhere, we can't do the spam assassin trick of just going and filtering everything out. So somehow we need to be assigning, possibly one solution is to assign reputation to users. So obviously, let's talk about reputation quickly. Users need to be able to filter out low quality content. Now that can be anything. It can be obvious spam, it could be offensive stuff, it's stuff they don't believe in. Who knows, it's somebody they don't like, it's their ex-girlfriend, whatever. In a global neutral system, this has to be morally relative. We are not in the business of doing DNS blacklists which say this person is a spammer, please never receive anything from them. Instead, we need to let people curate their own blacklists or their own grey lists, because, you know, you've got one guy guy's terrorist is another guy's freedom fighter, one guy's spam is another guy's direct marketing. And obviously just because I want to filter out certain political yabbering doesn't mean that you want to do the same. But we have to do this, as I hope everybody agrees, by not creating a filter bubble which goes and transparently filters things out based on what your friends say. Otherwise you end up in the dystopia of Facebook that we have today, of everybody's prejudices being reinforced because they can't see the other side of the view. So we have to do this in a way that users can visualize and curate the algorithmic filtering that's going on. So possible solutions. Well, the thing that I've been thinking about the most is basically letting every message in Matrix be rateable in a very free-form way. So you can have upvote and downvote buttons on a message, or you can go a little bit further and do Facebook or Slack style reactions to them. It could be tags, so literally just say, well, I'm going to tag this as spam, and I'm going to tag this as genius, and I'm going to tag this as stupid. And you can obviously see that the richer the rating, the more risk that the rating itself needs some kind of moderation system. So you want to keep it probably as simple as possible. It's worth noting that even simple up and down voting can go wrong. So if somebody does something embarrassing, you can even abuse that person by deliberately upvoting it so everybody can see the embarrassing thing they did. So very quickly, last slide, reputation solutions. Possible solution is that you take all of the upvote, downvotes that you've seen, and it forms an implicit social graph. So we're not forcing people to say, I'm friends with this person, but just the fact that you've gone and repeatedly downvoted them probably means you have some kind of implicit relationship to them. You can then detect Sybil attacks and possible voting rings by doing cluster analysis on that graph. You can correlate them with the content in the public messages, not the end-to-end encrypted ones, and help visualize reputation. And that could be presented as something like 95% of users who like this message also like whatever. Then you can also look at transitive trust. Oh, by the way, 90% of your friends like this too, which is a useful data point, even if you choose to ignore it. And critically, you have this huge UX challenge of letting the user curate and visualize. So 70% like it, 90% hate it. You want to do it anonymously because you don't want to be gathering metadata on who likes who on a global basis. So it's at least got to be pseudonymized. And you can also have other indicators like IP address, ISP rating, blah, 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 in there. So spam can be done the same way. You can make people spend money to talk, and that's hard, and might be over-engineered, we don't know yet. Everybody needs it. It's not just Matrix. We're talking about basically having a flexible identity reputation layer for the web in general. Come to the talk this afternoon at 3 if you want to hear about crypto and metadata privacy. What's next? Lots of cool stuff, which I just said. We need help. Please run servers. Thank you very much. Thank you. Any questions, if we have any time?
1 minute and 30 seconds for questions.
Quick.
And answer.
Anyone?
These slides are available.
Sorry?
These slides are available.
Yes, yeah, I'll go and publish them on the blog afterwards. The slides will be available on the blog.
You mentioned indie web with the
WebFist.
There is also indie off.
Sorry, indie which?
Indie off.
Okay, yep. Yes, so the indie web community, indie off, are looking also at solutions along this lines, and I've spoken a bunch to some of the indie web guys. Nobody has yet sort of said, well, clearly you just need to use this, we solved this already. But somebody must be. It's kind of, everybody's trying to work towards the same thing. We must be nearly there.
Yeah, you put on your website that you have this Facebook, this email, this GPG, this phone number.
Right, so, I mean, is that like WebFinger? Basically,
Web signing, yeah.
Yeah, so the W3C has a working group looking at basically solving this sort of thing, so you'd hope that we're going to get there eventually. And repeating the question, it was whether there is